Hi, I'm Jim Moore here with the SEMA Garage in Diamond Bar, California, and here to give you a little bit of a tour behind the scenes of what we do at this Product Development and Engineering Center. So let's take a tour. Well, I think anytime we take a tour of the SEMA Garage, we kind of have to start out with what is it and why is it here? Every manufacturer needs to bring products to market and they have to go through a product development journey. How do I get those products from my mind into some sort of paper or digital form? And ultimately, how do I prototype it, test it, and then show any level of regulators that it meets any safety or other emissions certification and compliance necessary? So that's really what we do here at the SEMA Garage is how do we minimize those common pain points along the product development journey, helping to streamline that product development process to get those products to market faster and in the hands of end consumers. Virtually any manufacturer, regardless of the product they make, hits the same common pain points along that process, which is first you have the ideation. How do I develop this product? I have to picture it in my mind and somehow convert that idea, that concept, into some sort of physical or digital form. SEMA runs a program called Tech Transfer. And Tech Transfer really is simply a catalog or a database of digital information of vehicles so that any manufacturer, say I want to create an airbox for a 2022 Ford F-150, you can actually download the original CAD file, the OEM level CAD file, and see the engine surrounding airbox, remove that airbox and start building your new product in exactly the same space, understanding every wire, hose, bolt, and chassis that exists around that so you can understand how that's going to ultimately fit in. And that's really what this program is all about. But not all manufacturers give us OEM data. So a lot of manufacturers, we have to physically scan parts. And that's what Matt is doing right here. Matt is one of our product development engineers using our laser scanner. And you can see right here, he's working for a particular member that needs surface data, dimensional information on a transmission mount. And this looks like it probably goes between the transmission and an engine. And if you come over here, you can kind of see what he's doing. It almost looks like he's spray painting this device. He is, in a sense, spray painting it, but he's painting it with a laser. And that laser is getting really critical dimensional information. When they think about like how accurate is this information, this information is down to fractions of the width of a human hair. Every bolt hole is going to line up perfect. Every surface is going to be flush and flat. The next natural step in that process is, okay, how do I get that file off of the paper or out of the computer into my physical hands to be able to explore its actual function in real life on a part? And that's where we get into things like additive manufacturing, 3D printing, the ability to take that file out of the computer and physically put something into your hands. This is an example of an air intake that probably took around 12 to 14 hours to print. And that's pretty remarkable because not too long ago, you would have had to buy a giant block of aluminum. You would have had to spend probably 30 or 40 hours programming a CNC machine to cut that piece of aluminum. And then you would have produced this at significant cost. And then all that is before you go to test it. Well, what happens when you test it that you find that there's some unintended or unanticipated function of it? So you start that whole process over again. 3D printing has allowed us to significantly compress that prototyping process down to just a mere few hours. To be able to, again, take that file, render it, 3D print it, have it in your hand, and now you can take a physical product like this 3D printed air intake, bolt it onto an engine, and actually see how it functions. And our ability to print and make those types of products, whether it be something very small, something as big as maybe a full engine block. This particular engine block was used for fabrication purposes to really understand physically how an engine would sit in an engine swap environment in a different vehicle. I think this is actually a 2.3 liter EcoBoost Ford engine that was put into a mid-70s Ford Maverick. So as much fun as all this technology is, here's where in my mind the real fun starts. Let's go into the garage. So this is our installation center. kind of a multi-purpose area that allows our members to do a wide range of functions and activities. We have our members that come in here, they can do fabrication, they can do electrical work, just about anything on the mechanical spectrum. Over here we've got all of our vehicle alignment relating to a number of our new ADAS technologies and such. And we can't simply assume that all these technologies function as intended. So SEMA is actually out there doing physical testing of modified vehicles to understand the impact of that. Anything that we anticipate that our members might need to do to get their products to market, and this is where it all starts to come to life. Any products that ultimately need to be tested, this is where we do the testing. This is our emissions compliance lab. And there's a very prescribed process, and it starts with what they refer to as soaking the vehicle. We have to put the vehicle at an ambient temperature for a fixed period of time to ensure that that vehicle has no heat in the catalyst or the engine or any other element that could impact the functionality of the emissions device. So what they'll do is they'll take that vehicle, they'll modify the vehicle, and then bring that in here, let the vehicle settle to an ambient temperature, take the vehicle from this soak room that you see here, move it over here into the dynamometer lab, and start the test before the vehicle key is actually turned. Within the automotive spectrum, emissions specifically, the vast majority of the emissions take place when the vehicle is first started, before the catalysts actually heat up and start functioning. So it's critical that we show how much emissions changes with that new product installed in that period, as well as while it's driving at speed. And to help ensure that all of these tests are equalized, there's very specific tests that go through where you have to follow a very precise line to accelerate, brake, fast on the throttle, light on the throttle, coast, to ensure that regardless of whether that test is done here in California or in Detroit or any other of the certified labs around the country, those tests are always the same to get consistent results. Thank you for visiting the SEMA Garage. If you have any questions, you want to learn more, check us out at semagarage.com.